So yesterday we are discussing the data warehouse concepts. Okay, and before that we have discussed database concepts. And in data warehousing, we have seen like what is the data warehouse, okay, what is the purpose, and how the data is stored in the data warehouse, like tables, okay, fact tables and dimension tables, and the design of the data warehouse, like star schema, snowflake schema, yeah, that stuff. And what is the difference between star schema and snowflake schema? Okay, so and we also learned that dimension tables over the time will tend to change. Okay, the dimension tables will tend to change over the time. Okay, so yeah, so those are categorized as slowly changing dimensions, SCD, slowly changing dimensions, type 1, type 2, type 3. Okay, so slowly changing dimensions type 1 means they will maintain only the current data. Okay, so if we see in our real time in our projects, there are some set of tables which we are maintaining only truncate and load. Okay, truncate and load means delete all the data and load whatever data file that is coming for today. Okay, and the data that is coming today is the latest data. Okay, just truncate and load. So the ETLs that you built, okay, or whatever the developments you have done, truncate and load, they are actually the SCD type 1 tables, slowly changing dimensions type 1 tables. They will have only current data. And the other type of tables are called SCD type 2. Okay, so in SCD type 2, you will be maintaining the complete history. Complete history means since beginning of the record, we will be maintaining. Okay, so when we have to maintain history, then new records we should insert and existing records we should update. Okay, and we should not delete any record. If a record has deleted, you have to update its end date. Actually, I will tell you, I'll talk more about SCD type 2. I mean, just after covering SCD type 3. SCD type 3 means current data plus recent history. Means current data plus last 3 months data, or current data plus last 2 months data, like that, or current data plus last 6 months data, like that. But it is not going to have complete history. Okay, so the complete history that we are going to have is only in SCD type 2. Okay, so how do we maintain SCD type 2, okay, for tables? So generally SCD type 2 is implemented with one of these three methods. Okay, like date range method, they call date range method, start date and end date will be there. And another one is called flag. Flag means apart from date range, they also will add another column called flag, and the other version is called version. Means actually, since it's going to have the version history maintained, so that means there is more than one copy of the record that exists. Okay, more than one copy of the record that exists. So they will maintain the flag stating which is the latest record. Which is the latest record. For example, you see something like this. See here. Here there is a last column called is current is a flag. Okay, so the employee ID 1001. Okay, initially it started 01/01/2020 and it ended 12/31/2021. He worked in SC department, and from 01/2022, see this record is only 2021, and the new record is from 01/01/2022. He working as an architect. Okay, in a different in an architect department. Okay, and his salary also got changed. So that is also not current record. So then he worked in architect department only till 31st March. And from 1st April, he joined in BA engineering. And his salary also got changed. And here the end date will be high end date. This is called high end date actually. Yeah, 9999/12/31 actually, or 31/12/9999, anything is fine. So 99991231 is actually high end date. We generally use in our real time as the open record, or which is the current record. This is to indicate the record which is open or active or current record, and is current flag is also Y. So this method talks about flag. Of course, flag will also have date range, start date and end date. And if you see this particular 102 record, it has only one change. Okay, there's no other changes after the employee joined. So start date will be 01/01/2022, means he joined, that is the date, and his end date is 9999/12/31, means he is currently active and he has not made any internal changes or anything. Okay, no promotion or nothing. So from the joining date, he is still working with same department. I may be a senior architect, SRDRC. Okay, so and there is no change in salary and all, so same. So let's say there is some change. Okay, for example 102 record. Okay, for example he joined on 01/01/2022. Let's say after he joined in the at the end of this January 31st itself, he moved to a different department. Okay, so then how this record will be maintained is, we don't just update this record. Okay, what we do is, let's say till January 31st you worked in this department, then this record will become like 31/01/2022, means we will update the end record of the old end date of the old record, and the flag, if there is a flag. Okay, if there is no flag, then we don't update. So till the date to which he worked in that department, we'll update the end date, and the start date will be February 1st. You see 01/02. So the next date will be, I mean, when he moved to a different department. For example, he changed from senior architect to for some project management. Okay, so then the project management date will be after this date, or in other words, the date, if the project management date is February 1st, then the existing record end date will be this date -1, means current role date -1. Current role date is February 1st. So the existing record end date will be current date -1. I mean the current start date in this new project -1, that is 31/1/2022. Okay, and if there is a flag column maintaining in the design, then you will update that flag column as the end. And the new column end date will become high end date 9999/12/31. Okay, so this is high end date, and of course his current flag will be Y. Okay, so everyone working in the IT, they must be seeing this SCD type 2 implementation, because this is what every customer will be implementing, because complete history will be maintained, okay, for majority of the tables, and this complete history will give complete idea about how particular record or how particular employee or customer record is going through, like from which date to which date. Okay, he worked in which department, and which date to which date. Okay, what is his salary. Okay, whatever maybe the changes may be in salary, or the changes may be in designation, everything will be reflected, and only the latest record will have, okay, 9999/12/31. Okay, all other records will have their, that particular record end date will be there, maybe some end date. See this 101 has more than one entry because he made more moves within the company. And that's why the previous entries are all have close date, means end date. For example, it is clearly visible here. This particular employee worked in SC department from this date to this date, and the same employee worked in Arctic department from this date to this date, and during that date, this is his salary. And right now, this is his salary, and he is working in so and so department, and he is working from so and so date, and till now he is currently active in this role. Okay, so basically this is what SCD type 2. SCD type 2 means we will maintain complete history. Okay, so yeah, sometimes you see here we implemented flag, date range, date, and version means you see they will maintain instead of flag they will put version here. Version means latest record will have the like version v1, v2, v3 like that we maintain, right? Like that. Even for documentation when we are putting version 1, document 1, 2 or 1.1, 1.2, 1.3. So that means highest version is the latest record. But that most of the customers are not using version. No worries. Okay, so either they use current. Current flag also not many people will use current flag. But the widely used method is date range method. Means they will have some start date and end date like this. Start date and end date. And the start date will be record start date and end date will be high end date. Okay, high end date means 9999 Okay, if any record, for example, here this particular employee has left the company, let's say, or this 103 Raj has left the company March 31st. Okay, so this particular employee has left the company on March 31st. Okay, so then you see if he left, we don't delete the record, rather see how it will be. We close the existing record with high end date as when he left with his last working day. For example, he left on 31st March, then 31st 03 2022. That's all. Okay, so his end date has some valid date means he has left, means his record got closed. For example, if the employee leaves the company, what happens? It's not that they will record our employee record from the employee database or employee table. No, they only will update our end date with last working day. If they delete the record, our details are gone, right, from the company database. So in SCD type 2 table, if an employee leaves, they will just update the end date with the last working day. That's all. They don't delete the record. So that is what SCD type 2 means. Even if the employee leaves the company, they'll just update the end date with last working day. If he stays the company, if he's still in the company, then his end date will be, if he's there with the company, then what is his end date? His end date will be high end date. Okay, actually high end date is the actually indication that particular record is the current active record. Okay, so these are current active records. So one of the
Hello.
yes.
So Krishna, who will be updating this one? Whether that load job will do this update in the high end date and the is current flags?
Sorry.
No, this updating the end date and is current flag. This will be done by
Okay.
the load job in the everyday batch.
Yes, load. We only will put that logic right. Yes, load. These are all things that happen during the ETL loads.
ETL loads.
Yes,
Okay.
load job. Yeah, load job only. Because data loading will happen through load jobs only, right? This is the data load that happens everyday file. Every day our load job will run, right, extracting the current day's file. Okay,
Okay.
so the load job only will do that. In fact, this is the logic we write for SCD type 2 tables. If the records are there, update. If new records, insert. That is the ETL logic we write.
Okay.
Yeah. So yeah, that's what actually our ETL developers we do. What we do is we do develop ETLs, right? So that's what ETLs are, like SCD type 1 logic, SCD type 2 logic, SCD type 3 logic. For example, I will tell you one more. SCD type 3 means SCD type 3, yeah, this is SCD type 2. Now SCD type 3 means what? Current data plus recent history. Current data plus recent history. Recent history means last 2 months data or last 1 month data. Current data plus last 1 month data. Current data plus last 2 months data. Or current data plus last 3 months data. Or current data plus last 6 months data. So I will tell you one query. So that will help you. See, if you see in one of the developments, we are adding post session query. Post session query means after the table load is completed, we are using this query: delete from table name, delete from table. I mean, whatever the table may be, where, okay, load date. I mean, some date column will be there. Load date greater than date minus 90. What does this logic mean actually? Every day you're loading, and after loading the table, you will run this as a post SQL. Post SQL means after the table, this SQL will run after the table load is done. Load means your load job or ETL job. After because every day it will run with the that particular day's load file or data file, source file, and after the table is loaded, this particular post SQL run. Post SQL means the SQL that will be run after the load. So delete from table name where load date greater than date minus 90. Okay, that means, do you know what it means? I think Jagdish can answer. Jagdish, do you know what is the SQL? Hello, Jagdish, are you there?
Yeah. Yes, I am there. Yeah, we are deleting the records where the load date is greater than date minus 90, which means we are deleting the records more than 90 days.
Yeah, so this is what SCD type 3 means. Means we want to maintain only current data plus last 90 days data or last 3 months data at any point of time. Okay. So yeah, so this is the logic, okay, for STD type 3. So STD, as I said, some companies will want to maintain last 3 months data or some last 6 months data like that. So as an everyday load files, after in post SQL, this will be run. That means every day it will maintain only 90 days. Okay. So yeah, so like that. Okay, STD type. So this will be implemented. But in STD type 1, what is the query that is written in STD type 1? Because SCD type 1, it will maintain only current data. So for current data, how do you maintain current data every day? SCD type 1, how do we ensure SCD type 1? Jagdish, any idea?
If we need to get only current data, means 1 day data, means we can.
So delete everything greater than 1.
So issue the delete before the load.
Sorry?
First we have
When
to
you load,
issue that delete. After that we have to load.
I think it will load,
That's right.
then
That's
delete the
right.
old one.
No. Delete. Yes, truncate and load. Okay. Delete and load, or yeah, delete sometimes even slower. So truncate and load is the SCD type 1. Okay. Because every day you will get the latest data and you have to just keep that data and delete whatever is there. So that's it, truncate and load basically. Truncate will be faster. Okay. Or of course, if it is small tables, delete okay, whatever is there and just load the current file. Right? Yeah. So these are the different activities we do as ETL stuff that we do in our company. Okay. So any take, maybe you are like a legacy some ETL background, okay, or the current data engineer working on latest cloud technologies and Spark, okay, by Spark, okay, or Scala or whatever it is. This is what you will be doing. Okay. In fact, the same data warehouse or IT stuff is same. Get the files, load the data into warehouse, and get your BI done. This same thing will exist. Okay. And all the tables that we maintain are this one only. Some tables with current data, some tables with current data plus recent history, like SCD type 3, and some tables with complete history, current data plus full history, that SCD type 2 that I have explained. Okay. So in SCD type 2, as I already said, okay, start date, end date will be there. Okay, and date, start date will be record start date, and end date will be end date. Okay, so new records means inserted, old records means updated, existing records means updated. So that's what it means. Okay, cool. So that is about SCDs, like SCD type 1, SCD type 2, and SCD type 3. Okay. So of course, there is one more term in data warehouse that is called surrogate keys. Okay. So surrogate keys means in table is in database terminology, we have primary key. Okay, but primary key is unique and not null. But in database data warehouse, there is nothing like primary key. For example, you see here we are maintaining the history. Okay, employee ID is the primary key in employee table. But when it's loaded into warehouse in the table, where is that? Even we can see 10013 entries. Okay, because we are maintaining the history. So primary key and those things are not going to work. So we are going to have one ID that is called unique ID. Okay, for all the records that we going to have, that is called surrogate key. Actually, surrogate key means data warehouse keys are called surrogate keys. Okay, data warehouse keys are called surrogate keys. Okay, that is to ensure uniqueness in the data warehouse. But it's not that all the customers will use surrogate keys. In fact, in some, okay, in old designs, they used to use surrogate keys. Okay, I mean, if they are using Informatica, they used to have something called sequence generator transformation. Or if you are implementing through sequels, they have something called sequence, okay, or identity column to generate, okay, some unique number for every insert or update that you are happening on the data warehouse table. But this surrogate key actually is not much useful, and the latest designs are not even using the surrogate key because it's just a waste of some space. Okay, cool. So yeah, this is what ETL developer means will do: extract, transform, load. Okay, so earlier we used to call ETL developers. Okay, basically they will be working with some Informatica data stage, Ab initio, some tools. And now the term got changed, and the same people are called as data engineers. Okay, so data engineers. Okay, data engineers means they also will extract, transform, and load, but the tools that they use will different. They will use something like, okay, even Redshift or Spark, PySpark, Glue. So these things. Okay, so okay, now let's start Redshift architecture. Okay, so we are entering into the main course. Okay, so as we know, Redshift is a cloud data warehouse. Okay, so Redshift is a cloud data warehouse. Okay, So what is Redshift? Redshift is a cloud data warehouse. Okay, fine. Earlier, yeah, we know about data warehouse on premises. Means even if you go to office, there is a server room. Okay, there are some system admins, network admins, and they used to take care of that system or server room. Okay, so but what companies like AWS or Amazon, what they did is, I mean, why should everybody have their own server rooms? We will maintain the data centers. They can pay for whatever services that they want. Okay, something like the postpaid Airtel bill that we are paying. Okay, so
Punjabi word.
we can have,
సో డిస్ట్రిబ్యూషన్ వాడు మొత్తం వాడిదేమో ఒక డిస్ట్రిబ్యూషన్ ఉంది వాడికి. ఈ విల్ మొత్తం వాడే తీసుకుంటాడు.
okay, so what they come up with the plan is, why everyone should have server rooms in their own, okay, on premises. We will maintain the data centers and they will pay for the whatever services they use, something like Airtel postpaid that we pay, okay, and or something like current bill that we pay, electricity bill. You see, we cannot maintain powerhouses and power grids and generate our own power because it involves a lot of investment and all. And similarly, we cannot have our own, telephone towers and all. So, what companies like AWS did is they have data centers all over the globe, and companies can use whatever services they want, and they pay only for what they need. Okay, so even the data warehouse, earlier people are using, like, the Oracle data warehouse, MS Microsoft SQL Server, and Teradata and all. But now even those databases, okay, they became, I mean, cloud data warehouse came into picture. Okay, cloud data warehouse means you don't have to have your own premises. Okay, we maintain the data warehouse, you use it and pay for how much time you use it. And unlike like our postpaid bill, it's not that if you take some plan you have to pay that particular amount. No, if you use it, then only you will pay. If you don't use it, you don't even pay. Okay, so you take the service and don't use it, and you don't get the bill. So like that. So okay, so Redshift is a petabyte scale columnar cloud data warehouse. That is the way we define. It's a petabyte scale. Petabyte means 1024 terabytes. Okay, and like that it has many petabyte scale. Okay, thousands of petabytes. It is thousands of petabytes. Redshift is a petabyte scale columnar cloud data warehouse. It's a columnar, and all the current data warehouses are row level. Okay, we will be discussing what is the difference between columnar and row level and all. Okay, so Redshift is a petabyte scale columnar cloud data. It's a cloud data warehouse. Cloud means it will be maintained by some cloud service provider. Okay, you don't have to buy hardware. You don't have to buy, okay, any software. You don't have to do any patching, versioning, upgrading, nothing. Everything will be taken care by the service provider, like AWS is providing. Okay, Redshift software also he provides, hardware also he provides. You will just subscribe. Subscribe means he will provide you, like we get telephone number as the customer ID, or like you get uh, phone, okay, telephone number, okay, or a current SC number, unique service number in case of your electricity bill, something like that. Here they will provide AWS account number, okay, where at the time of subscription. Then based on that, whatever you use, you will get the bill. That's all. Okay, so how much you use, that much only you will be getting the bill. So then what is the advantages of the cloud data warehouse is that, you see here, you don't have to purchase hardware. Okay, you don't have to worry about OS, like operating system patches, versioning and all. Okay, and the storage will be auto scaling. You don't have to plan your upgrades. Okay, you don't have to worry about maybe my disk is full, what should I do? Or on premises, even software, for example, if anyone worked in Oracle, they must have worked from Oracle, like V6, V7, or something like 8, 7, 6, 7, 8i, 9i, 10g, 11i, 12 rack, and all these things. For example, I worked on Teradata from V2 or 5, V2 or 6, then Teradata 12, 13, 14, 15, 16, then 17, 17.10. So many versions, and every time where there is a version upgrade, we have to plan. Okay, we have to keep the jobs on hold, and we have to do our upgrade, and we have to catch up the jobs, and this is a whole long-term plan we use it to do every time. And of course, hardware, that is again a version upgrade, that is a software upgrade. Hardware upgrade means it's even much bigger task, like adding number of nodes. Okay, for example, my system initially I started with some 30 nodes. Okay, but capacity is not sufficient. Now we want to add some 5 more nodes. It requires a long planning from 2-3 months. Okay, selecting the dates, keeping the jobs on hold, revoking the logons before the upgrade, and then upgrade, then making sure the system is up. Okay, once the system is up, enable the logons, and then again do the catch up of the jobs for 2-3 days. And even if something goes wrong in between, it's even nightmare. So now, okay, so now all these things are not there. Okay, so with AWS, even upgrading or software upgrade, okay, version upgrade, everything will be taken care by them only. Okay, so they'll provide us, okay, a maintenance window, like weekly once, half an hour window. Okay, they will ask us, okay, what is your comfortable window, 30 minutes window, so that they will do all these maintenance activities like patching, versioning, everything. Okay, and of course, if you want, you can escape also from that maintenance window. You can have your own timings whenever you want, and if you want, you can skip 1 week and maybe 2 weeks once, you can do. That flexibility is there. So yeah, and of course, and even any window they will be doing, we are not worried about it. So that is the beauty. Okay, cool. So Redshift is a petabyte scale columnar cloud data warehouse. Okay, so then okay, let me tell you what is this data warehouse, like how it came into picture. So as I already said, if someone is from Postgres, I mean, they will be having very good idea. So actually how the data Redshift came into picture is, they took the open source Postgres. Okay, they took it and they customized it, they changed it. Actually Postgres is a ANSI open source SQL. Okay, so it's a relational database, means row level storage, and SMP means single node architecture. Okay, where all your data is centrally stored. So they make Postgres and they made it into MPP. MPP means massively parallel processing. Okay, MPP means massively parallel processing. Okay, and they made the storage from row level to column level. Okay, actually all the databases are row level storage. Okay, so they changed the storage row level to columnar, and they changed from SMP architecture to MPP. SMP means symmetric multiprocessing, MPP means massively parallel processing, means multiple nodes will be there. Earlier only there is only one node that is centralized, but now multiple nodes will be there. Your data will be distributed across multiple nodes, and they have implemented some new OLAP functions, okay, which are useful for reporting and all. Okay, so all these together, they named it as Redshift and released in the cloud. Okay, so basically what is the base or from which they have developed Redshift? From Postgres. Postgres is again open source. Okay, so they took the Postgres, they converted from row level storage to columnar storage, they changed it from SMP architecture to MPP architecture, and they designed some OLAP functions which are critical for reporting. Okay, so specific functions related to Redshift. So the whole product, they designed it as a Redshift. That's the reason I said, if you know Postgres, you're almost, I mean, you are at least you can use the same thing, whatever you know in Postgres in Redshift, everything will work, including data dictionary tables like PG users, PG catalog tables. Okay, and apart from that, of course, Redshift has introduced its own catalog tables. Okay, and if you know already Postgres PG tables, then you can use it. So that's what. So now the Redshift is a cloud data warehouse which supports petabytes of storage. Okay, cool. Then okay, so then we said we let us see what are these features about. We said it's columnar, right? So what does it mean columnar? Okay, let me. Yeah. So columnar means your store. For example, wait, I will show you one more slide. Yeah. So, for example, how the row level storage means, for example, you see this is our table, okay? And table means rows and columns, SSN, name, age, address, city, okay, and some street, okay, that's the entire record, okay? Even Redshift table also, yeah, for example, table will look like this, okay, SSN, name, age, address, city, street, and all. But how the row level storage within the disk look like is in on-premises databases, entire record will be stored at the disk level. See here, entire record, that 101259797, and his name is address city street, okay, in the block, in the disk, okay, it is stored. And the next record, so entire record will be stored at the disk level, okay, in every block. But in columnar means entire column will be stored in each block. See here, only SSNs are stored here in block 101259797 and 89237582. So entire SSN will means entire column will be stored at the block level here. And similarly, next block name will be there, and the next block age will be there, and address will be there in the next block, like that. Not the entire record. Record means this horizontal line. Horizontal line, entire SSN name, age, address, city, state. So here the entire record will be stored at the block level. That is row level. And columnar storage means entire column. Okay, how many values will fit into, actually block size is 1 MB block actually. Okay, so in 1 MB block, how many SSN values will fit, that many will be put there. And yeah, and the next values in the next block. And similarly name, okay, how many values will fit in another block, they will put like that. Okay, then what is the advantage? Actually, if you work extensively on databases, you will know all the row level databases or relational databases, they are IO is a bottleneck. If you work advanced and performance optimization, you would be hearing that, okay, IO is the issue, so that is the reason jobs are running slow. Okay, So IO issue is the acknowledged problem with the relational databases, because we generally query, okay, maybe SSN number, or a table may have 100 columns, but we hardly fetch maybe some 5 columns, 10 columns, 15 columns, or 20 columns. Okay, the table may have even 100 or 200 columns, it does not matter, but we will be fetching only what columns we need for our reporting purpose. So actually that means, since data is stored in row level in on-premise databases, so it has to fetch the whole record into the memory, and it has to process. That's where it is spending all the IO. Okay, so IO is an acknowledged problem in the relational database. So that was addressed in the cloud data warehouse. All the cloud data warehouses, even Azure or Google Big Cloud, even Snowflake, they're all columnar storage only, because it's an acknowledged problem. In columnar storage, they only store column values in each block at the disk level. So that, because as I already said, although our table has 200 columns or 100 columns, we fetch only whatever columns we need for reporting, like 5 columns, 10 columns. And that 5, 10 columns are there in a certain blocks, and it will just get them. So we are basically saving a lot of IO through columnar storage. Okay, so that itself adds a lot of performance for the cloud data warehouses. You see, columnar storage is optimizing analytical query performance. Okay, and reduces the overall disk IO requirements. Reduces the amount of data that you need to load from disk. Yeah, as I said, in row level you have to pull all the record, irrespective of whether you need other fields or not, into memory from the disk. Okay, but here you will be fetching only the columns that you need into the memory for processing, and each block holds the same type of data. Yeah, and this is another important point. Since here entire column is there at the block level, and the column means what? SSN means it's a maybe some integer or something. Name means character. So SSN will be there in one block, name will be there in another block. That means entire block will have same data type. But whereas in row level storage, since entire record is stored, and record has multiple columns with different data types, so different data types will be there in each record. So fetching different data types also means it's like more IO occupying. Okay, so it adds up overhead with for the performance. So that's why column level will improve the performance. Okay, because all the values will have same data type here. It reduces the amount. Okay, each block holds same type of data, and block data. So block data can use compression. Yeah, compression scheme. Okay, selected specifically for the column data type. Yeah. So, and here the data is by default compressed. Okay, I will tell you. I will talk about compression. Yeah, as the next concept here after this columnar storage. Yeah. So, and a whole block will be compressed. Compressed means, yeah, the compression technique is there already in other databases also. If you work within database, even with Teradata, it's there. Okay, so compression means it's a column level property to reduces the space of a table at the disk level. Okay, what is a compression? It's a column level property that reduces the space of a table at the disk level. For example, here you see we have, for example, 6 columns. Okay, and SSN is an integer, name is a character, age is an integer, address is again character, city character, state character. So, and if this table is like 1 terabyte table, or some, let's say it's some 50 terabyte table. I have seen even 100 terabyte table, single table 100 terabyte I have seen. Okay, so let's say this is some 50 terabyte table. Then you see, then compression you can greatly improve. What happens in compression is it will store all the values. It's like compressed zip. That's why you call compress. Okay, it will store all the values internally. Okay, and especially you will gain more benefit with compression if you have repeated values. Okay, repeated value. For example, if you take city, even it's 100 million or 200 million records, cities you will hardly have some 50 values or 100 values, right? But table may have 100 million or 200 million records. That means all 100 or 200 values, only these 100 cities are only repeating. So that means there's a lot of space that is occupied by the repeated values. So when we compress, all those values will actually occupy less space, because it will internally store only that whatever unique values are there, it will occupy this space. Okay, rest of the space will be freed up. So like that. And Redshift provides different compression. Okay, so for example, I will show you. I see, for integer data types, one type of compression. Okay, for character data types, another type of compression, like that. Okay, for integer, big int, small int. Okay, so these are the different compressions that we use. I mean, we use means actually Redshift recommends not to specify compression at the time of creating a table. The thing is that when do we define compression? See here, create table, table name, okay, column, data type, and encoding. Here the term encoding is called actually the compression. Okay, encoding is the compression actually. In the other databases we use the term called encode, but here we don't use the term encode. Okay, we don't use the term compression. Here we use the term called encode. Encoding means actually the compression. Okay, so for example, you see, here also we create the table, like create table. Okay, create table, department number, integer, name, location, and all like that. Okay, here see this table is there, right? So this table is the output of the show table. Show means it will show the detail, but this table is originally created like this: create table, department number, integer, dname, varchar, location, varchar. It was originally created like this only. Okay, so here we have not mentioned anything. Okay, compression or anything. We just created like we do with other databases: create table, table name, and this style also we don't mention. I will talk to you about them separately. So we'll create like this only. But if you give show table, it will show the detail like this. If you give show table, means it will add encoding. Okay, here you see encode AZ64, encode here LZO, like that. It will add different encoding. Encoding means here it's a compression. Okay, compression. So compression is there in every database. Similarly, here also it's there in Redshift. And what Redshift recommends is, don't define compression at the time of creating a table, because if you define some compression, okay, and one thing we should learn in the IT is that what is best today is may not be the best after 2-3 years. That everyone should accept. What is the high-end configuration today definitely is not the high-end configuration after 2-3 years. So based on the experience over the years, people who define tables with compression, okay, when they started with Redshift, that compression is not the most efficient compression today. because today even much more advanced compression things came, means which can greatly reduce the space of the columns or space of the tables. So, and what they are trying now, hey, we have defined the compression, but our table size reduced, but okay, some extent it reduced, some 30% reduced, but we want 50% compression of the table. Okay, then what is, create the table without any encryption so that it will automatically pick up this latest encryption. Okay, when you don't mention any encryption at the time of creating a table, it will automatically take the latest encryption and create the table. You can see that using show table. So that because these encryption, they keep changes, because as the AWS is keeps innovating with latest and newer and advanced compression techniques and all. So with old compression, if it is saved 30% of the disk space, with new it is saving 50% of the disk space. So the best practice is don't mention anything. Okay, at the time of creating a table, just create your table as usual, and Redshift only will take whatever encryption that is required. So that will save the space greatly. And even after 2 or 3 years also, if your table, okay, if any new encodings come, no problem, table will automatically pick them up. That is another benefit. Okay, we don't mention anything at the table level, because definitely what is best today may not be best after 2 years. So even much advanced techniques will come, like compression codes. So that will be picked up. So that's the reason it mentions don't mention encoding, but this is our knowledge sake, like Redshift provides encryption to provide or to save disk space. Okay, so yeah, that's what we see. Okay, in the table EDL. Okay, so it's a columnar and it's compression. Okay, encoding. In other databases, the term is compression. Here, the term is encoding. Okay, encode. And there is another term called statistics. Okay, if you have worked with any other databases, there also you will see the term called statistics. Okay, I have worked with Teradata. In Teradata also there is a term called statistics, collect statistics and all. Okay, so here the term called analyze. Okay, you see all the database concepts will be there in every database, but you know some terms will change. Okay, some terms will change. What this, the purpose for which it is there is same. Okay, statistics. Okay, in other database it is called statistics, and here it's called analyze. Okay, so what is the benefit of statistics is, if you have the statistics, optimizer will come up with the best plan. Okay, during query processing. Okay, and what happens when you collect statistics is, or here what happens when you do analyze on a table means, it will come to know what is the size of the table, how many unique values are there for each column, how many duplicates are there, how many null values are there. So all these details will be known to the optimizer. Okay, the table may, for example, a city column in a table have 100 million records, but it will know like it has hardly 100 unique values out of 100 million, because city means what? You may have 100 million customers, but the customers will be one of the, they will belong to one of those 100 cities only, or one of the 1,000 cities, but it's not 100 million cities. Okay, so because many customers will belong to the same city. So like that. And pin code, you take pin code. And similarly, you take gender. The table may be like 100 million records, but the gender field will have either M or F, some two values. So when you do collect statistics, optimizer will come to know how big the table is, okay, how many unique values are there, how many duplicate values are there. Everything will be known to the optimizer, which it can use during query processing to come up with the best plan. Okay, And here also we have the color statistics. Okay, here also we have the best practices. Okay, when to collect statistics and how to represent statistics and all. Okay, and of course these are the database basics. Any database basics we should implement. And here I'll be showing you like how to collect statistics and how to check statistics on a table, whether the statistics are up to date or not. Okay, in the subsequent sessions. Okay, tomorrow we'll be seeing the other concepts. Okay, any questions? Jagdish, you are the person who has that Postgres experience.
No, actually, I don't have PostgreSQL, but I have database knowledge. So what I thought, all these queries which you have written, so I have idea, and any other things which we will be doing other than these SQL queries. That's a query I had.
Okay, I will show you. Okay, actually, see, actual Redshift session only. Okay, I mean today we just touched the Redshift. Okay, actually these are the things we are going to cover. Okay, so this is what actually the Redshift is. I think they have already shared you the contents, right? Okay, how to get started with Amazon Redshift. Okay, like how to subscribe and how to get create, and so yeah, like creating Redshift, launching Redshift cluster, creating role. Okay, creating your IAM role, and then playing around the cluster, loading data into the cluster. Okay, and of course understanding what are the components that are involved in a cluster, like ladder node, compute nodes, and slices, zone maps, and these things. Okay, like what are the sort keys, what are the distribution keys. Okay, how to design tables in Redshift with respect to performance, and how to create tables, schemas in Redshift, and yeah, how to write queries in Redshift, and how to load using Redshift. Okay, how to load and unload data using Redshift. Okay, and of course the other things like workload management and the Redshift spectrum. Okay, Redshift spectrum, then advanced concepts in Redshift. Okay, and again system tables in Redshift. Okay, system tables in Redshift. Okay, and Redshift pricing in different node types. Okay, what are different types of nodes? Redshift pricing and cost optimization, and Redshift snapshots. Snapshots means backup. Okay, how to backup, how to maintain backups, and how to what is the cost associated with that, managing clusters and snapshots, and performance optimization. These are the this is the actually core content of the Redshift. Okay, we just started. Okay, with the architecture. Okay, so
Okay.
if you are a database background, yeah, you may feel like okay, maybe little boring, but I mean everyone is not like you, right? Out of 5 people, maybe all these things, but it may be like
Yeah, I
refresh, you can
understand.
see. Yeah, but actual thing will start from, yeah, already started from today, like what is where from it originated. So where from it originated and how the design architectural changes has been done, what is architecture of Teradata, and what is the table design, physical database design tables and logical database design tables, what is this compute node, and how they perform during the query processing. And main thing is that how to load data into Redshift. That is the main and heart. Okay, that is like the highlight. Okay, how to load data into Redshift. Okay, so how to load and unload. That's what actually we do in our Redshift development. Okay, load and unloading into Redshift. So that will be covered, as I said, that will be covered in the middle. Yeah, because before that we need to know like what is sort keys, what is distribution keys, and what is this compression, and how to create table, that need to be covered basically. What are these slices, compute nodes, data nodes? Then this data loading and unloading will be coming into picture. Okay, and this is what we'll be doing. And in order to do that, we should be knowing at least the design level, like what is the distribution style, all, okay, distribution style eval, distribution style key, those things will be covered in table design. Okay, table design, you see this one, Amazon best practices for table design. So those will be covered. Okay, and yeah, then data loading and how to troubleshoot in case if your jobs are running longer. Yeah, and how to manage using workload management. So yeah, whether in how to using like Redshift Spectrum. Okay, what is the Spectrum first of all, how to query that, and what is the use cases of Spectrum. Yeah, actually, yeah, these are all the actually Redshift contents. Okay, sorry, I mean you may be feeling bored, but you know, maybe only initial classes, but not anymore.
Okay, yeah. Even the pipelining also, like the loading the data, because I
Yeah,
worked
yeah,
on
yeah.
so I feel all the topics are looking very similar, repeated. So that's the reason I informed to the coordinator,
Okay,
saying
fine.
like that.
In a pipelining, you work with Informatica, right?
Yes, yes, loading the file
Informatica.
data, those.
No, no, no. That is different. Okay, that is different. That's what I'm saying. Everything, even you see, even you go to BigQuery or Azure or even Snowflake, concepts will be same. Loading, extract, transform, load. Okay, ETL and ELT will be there. But how we do here is different. How you do using Informatica mapping, workflow, sessions, okay, that is different. Okay, but here the same
Okay.
thing, data loading only will be there, but the tools and utilities we use are different. Okay, that's what I said. That's why I discussed about SED type 2. Here also we do SED type 2 only. SED type 2, you know, right? In Informatica, you have used SED type 2 most aggressively. Okay, so it is SED type 2 only we implement here, but it's different. How do we implement? Okay, like copy command, unload command, so that thing. So there we call ETLs, here we call pipelines. Okay, there is also loading, here is also loading. Only thing is that for experienced people, it will become easy because they have similar exposure already. Okay, it will become easy because yeah, the same thing, but using a different command or using a different thing. That's all. There is nothing much. That's why we as experienced people will be like easily can pick up compared to the new people. Okay.